Hello everyone, this is Vasishta from Aerobase section. Today I'm going to explain about multi-purpose or flexible wing structure for small unmanned aerial systems. So, what are flexible wings and what are UAVs or unmanned aerial systems or unmanned aerial vehicles? So, we need a flexible wing structure for UAVs to function. So, introduction to the concept of flexibility. The concept of flexibility or morphing generally defines an aircraft whose shape is changing during the flight in order to optimize its performance. The changes of the aircraft shape include but are not limited to span, area, camber, chord, thickness profile, aspect ratio, and planform. The morphing can be used as an element of control by the variable shape aircraft to change the dynamic flight. In the past, the aircrafts have adopted different techniques for adapting their shape depending on the desired flight characteristics. So, the, knowing the introduction of flexibility, we need to optimize or we need to have a performance in order to get a good flight or good unmanned aerial vehicles or unmanned aerial systems. We need different types of aspects, and we have to conclude or we have to know the span, area, camber, chord, thickness profile, etc. in order to get a good flight. Coming to the review of current concept, Wright brothers. We have known that Wright brothers developed the first aircraft which has flown and made by wood. Wright developed the idea to change the airplane's the aerodynamic features by modifying the shape of the wings. So there are different types of wings we can see here. We have tapered wing, rectangular wing, a flat wing, and different types of wings can be made by airfoils. Different types of airfoils and forward swept and backward swept and dihedral angle and a hedral angle and elliptical wing. There are other methods is a variable dihedral angle for aircraft stability with the change of wingspan. The morphing technology is not limited to pre-operated aircraft. Developing a new generation of UAVs that is conjunction with the advanced technology material has led to renewed interest for radical configurations of morphing. The current research is dedicated to various wing shapes, but by the way of variable span, camber, and 3D structural. The current types of morphings are available with the 1D change, concept of morphing buckle wing, complex morphing wing concept generation, total morphing concept for UAV, multi-axial winglets, vertical bidimensional morphing, flexible flying wing concepts. That is the one-dimensional change of wingspan or the form of the wing can be split on the flight for different missions, making a large variation in span size in a limited section of a wing. In addition to differential span change between wingtips can generate a roll moment, potentially replacing ailerons on the aircraft. So, in 1D change, we can see that the wing can be split into two different types by changing its wingspan and the wingtips. Generally, wingtips are used to reduce the vortex formed in between. I mean, vortex formed at the edges of the aircraft, and ailerons are used to produce lift. They are used to control the aircraft when it is in flight. And concept of morphing buckling. The UAV with the 3D morphing has the capability to change the configuration of wings from a single one into two wings glued to the extremities. As we can see in this previous diagram, here in this diagram, we can see that there is a only wing with there's a two wings within the same point as here. So the wingtips are actually the same, but there is a two. I mean, there's a bi-wing. There are two wings attached to the one wing. This can be modified, this can be done in 3D morphing. And coming to complex morphing wing concept generation, there are aircraft with wings that have the capacity to change the shape of platform during the flight with a 200% aspect ratio, a 50% wing area, and with 20 degrees the wing speed. The concept of morphing by DARPA was further developed in the Phase 2 program called MEAS, Morphing Aircraft Structures. The wing folding concept developed by Lockheed Martin allows variations of the span, aspect ratio, chord angles, and effective sweep angles. As we can see here, a normal tapered wing can be changed into different types, different sweeps. It's a backward sweep angle. As we can see that here, it's mod swept, it's a medium swept, and it's a normal swept. And coming to total morphing concepts for UAV. The aircraft with the total morphings are flying vehicles that change their shape in order to accomplish the stated mission with the use of conventional control surface or scenes for flight control. The aircraft built with morphing technology promise the distinct advantages of being able to fly many types of missions. To perform radically new maneuvers not possible with conventional control surfaces. To be more fuel efficient and to provide a reduced radar signature, the key concept is full integration of control shape of wing structure with a truly intelligent structure. The design of these vehicles must take full account of the aerodynamic loads and must carefully consider the power requirements for shaping control to ensure an overall performance benefit. As we can see here, the control surfaces are here, but it can change, the wing can change its shape so that the control surfaces haven't changed their shape. And the experiment about the aircraft with surface adaptive APV or is a design of a university in Virginia. Or the UAV has a telescopic morphing structure in the wing, tail, and fuselage. The project was done to access or assess the benefits obtained in the next gen aeronautics. Since the results are not available, morphing concept for NMAS horizontal bidimensional morphing, a variable sweep, variable root angle concept was developed by next gen aeronautics that enable direct variations in root core length and sweep angle, thus indirectly varying the platform area as aspect ratio. MXF2 is capable of autonomous metamorphosis during the flight to adjust the wing in 10 seconds, thus allowing a varied angle for optimization at different schemes of flying. For example, as we can see in this figure, next gen aeronautics MFX2. And coming to multi-axial winglets, the multi-axial winglets are attached to the wings able to perspectively change their angle. They are not replace conventional surface control. They do not replace conventional surface control, but they use these two. They would provide improve the flight substantially. The next step in this research is to test a model with multi-axial winglets to replace the conventional control surfaces. And vertically bidimensional morphing. It is worth mentioning that the morphing changes the system of constant over time. Therefore, introducing new inertial terms in the dynamics of flight, the UAV with multiple degrees of freedom for translation and rotation must properly account for inertia to a high level of accuracy in order to model the dynamics of the flight. And flexible flying wing concept. The University of Florida made a research about deformable wings with the capacity to transform continuously. These wings are very complex and could be used for UAVs. The flexible wing allows complex forms and it is more stable than the stiff one. Particularly in turbulent weather conditions, the manual control of the wing shape is impossible, thus making necessary the software and hardware to control. The cases of flexible wing or inflatable wing, in which the wing inflates during flight and it is reinforced under the action of UVs during the session made using a balloon. Researchers from Dover has similar research with wings provided by piezo, piezoelectric wings. The wing is inflated and deflated according to the needs of control during the flight and is able to change the shape tips such as NACA profiles. The proposed model, as we can see, the method of transfer functions could be used for the analysis of dynamics of a flexible aircraft. In open loop architecture, a control is required to activate the process. Block diagram representation is also a suggested way to deal with closed loop systems. The feedback loop measures the output using the sensors, multiplies the variable of the measurements in adjustable gain, and then provides the feedback signal to the comparator. As we can see in this flight conditions, select the type of wings and aerodynamic optimization control for morphing configuration and with the structural analysis, aerodynamic analysis, stability analysis with the global performance of UAV with the measurements of performance and again adjustable gain. These are the equations which is the considered as the control based on the variable of status creating paramodynamic performances in the linear phase. Here x1 degrees is equal to 1 by c1 of x2 and x2 degrees is equal to minus 1 by t1 of x2 plus c1 k2 by t2y. And conclusion and future work of this given function is that the main limitations come from the extreme miniaturization and the complexity or impossibility for downsizing. Additional one should consider also the aerodynamic characteristics with lower lift coefficients, higher drag coefficients, more for systems with unconventional propulsions. There are further limitations. The limitations of the morphing concept for optimal wings are imposed by compliance and environment mechanisms or the physical and chemical characteristics of the materials used in construction of flying wings. The operating limits for UAVs with morphing could be atmospheric conditions in the flying zones. The special missions require the exceptional maneuverability capabilities of the MAV. Morphing solutions are analyzed and compared according to the global indicators focused on controllability and aggressive handling. Reduced manufacturing costs are further important in selecting a morphing strategy. Static nonlinear characteristics will fully affect the numerator of the particular denominator of the operation equal. So this is the concept of modularity in well adapted to the semi-flexibility concept purpose for flying wing with high elongation ratio and for measuring the response characteristics of flight maneuvers. So this is all about my explanation. Thank you.